Hello and welcome back to compiler programming. In one of the last videos with the coding, we cleaned up this import setup. So now we have a very nice way to import the functions, and then we can call those imports. However, if you notice here, we just do this straight away. We just kind of have something outside of the function call. And this is not really typical of how programming languages deal with the point where the program starts execution. So in C, you would have like main function. In majority of the language, you will have some kind of main function that is a sort of a reserved name. And when the compiler finds a function with that name, it assumes that this is the start of the execution. And right now we're not doing that. Moreover, if we try to actually have some other function, it will not really work because it will call the function end, and function end right now does the encoding, which is not what we want to be doing. So today I thought that we gonna start tackling this problem and allow our function to be encoded after it was done without actually doing it as we go, as it was happening with our JIT code. So what that would look like? Well, that imposes several issues. Issue number one is we need to figure out how to refer to other functions, because we have code in some places where we have, for example, I guess this one, where we call different functions inside of this code, and we right now refer to them by their name or by their variable. So this is a value that we can pass into call here, but if we don't really know, if we haven't outputted the code for this function, then we don't know the address where we would need to jump to execute it. And so it becomes tricky to figure out what needs to go in here and how we're going to deal with this. The whole refactoring, it's going to take quite a while, I'd imagine. But the basic idea is that we now have to move away from having these hard-coded names and move towards the setup where functions have sort of string names, and then we look up those names from the program, and program keeps track of those names. Yeah. So let's see how it goes. We will probably have to disable majority of the tests because whatever we do is gonna be very different from what it was before. I could keep all the current tests working and instead just create kind of a separate setup where we have new function builder that is not behaving like the old one, but I'm not sure that's the best way to go forward. So instead, let's just try to see what the changes would entail. So we have this function builder where we call function begin, which is, let's just look at what we are doing. Firstly, we are saving the buffer, and then we allocate this descriptor on temporary storage. We fill it in with the basic information, and then we create a builder. The tricky part is, I guess, this one. Although now that I'm looking at it, since we are using label 32 as the operand of the function, it actually doesn't really matter at which point we patch them up. So I guess we could keep the current setup where the values are given back right away, and we just delay the actual resolution of that label to the later point in time. That might actually work. So now let's look at what function end is doing. It does this stack reservation calculation, which is something that should indeed happen at the very at the end of the function. That's not really a problem. But besides that, it also it also resolves the epilogue label and does the epilogue. Okay, what if we try to change this to move, I guess, this stuff to be afterwards, and change this encoding to push instruction. So what I'm trying to do is I'm trying to delay the actual encoding as much as possible without breaking stuff. Okay, and this now changes to push instruction. I think it should have the same signature as encode instruction. And ideally, it should be fine, except for the prelude. Yeah, the problem that we would have now, so this part, these 3 instructions should be perfectly fine. But this first one that deals with the prologue, this is where we would have a problem. Previously, if you remember, we were like reserving space for these instructions and then patching it in afterwards. Then we changed it to the current setup where we would do the encoding in the function and that allowed us to just keep it as is. And now that we will have to move this stuff, we need to figure out something different. Let me think what I want to do here. I guess we are splitting this up after all. So function end will now not do any of this. I will put it back. So this is how it was before. And we will have another function that will deal with this. What does function freeze do again? Function freeze, ensure frozen. Okay, we do need to do function freeze. That's good. We don't need to free the instructions array because we will not be dealing with instructions here. And I will create another thing that is, I guess, function encode of function builder star builder. And it will do what was happening previously. And now if we try to build our stuff, it will work just fine, or at least it will build just fine, but the whole thing will explode terribly. So if you run the tests here, you'll see that we have basically, except for this first test with executable, nothing will really work. Like it's all pretty bad because we are not encoding any instructions. So whenever we try to call the code in any of our tests, it ends up being a problem, and we have a hardware level interrupt happening. Okay, but it gives us opportunity to do something better. And in particular, what I have in mind is we will when we do function begin, we already passed the program here anyway. So inside of the program, we will just create an array of functions. And inside of that array, we will kind of hold all of them. And when we say that the program is done, we will just encode them all together. So we'll iterate over that array and call function encode. How would that look like? Well, I guess we need to have value dot h. Let's look at definition of the program, and we would have, so right now we have this entry point. Instead, it will be just it will be array of function builders, and eventually we'll get rid of this entry point and replace it with this lookup of main function, as I mentioned at the start of the episode. But for now, we just say array function builder pointer. Maybe we should make it not a pointer, but the actual value is there. But for now, I want to make it as uninvasive as I can, so we can have something working as soon as possible. Okay. We call it functions. That's good. We will need to have a type def, which is pretty easy. Say function builder star, and like so. Let's try to build this. It works just fine. Now we need to change how the program is created. I believe we created something like program free, program find import. Okay, so we didn't create actually a way to create one of the programs, but that's fine. We can do it a bit later. For now, we just say functions is array alloc of array function builder pointer, and I don't know, let's also have 16 of them. Doesn't really matter. We should also free it at the end of the tests. So this builds, that's very nice. Now we can go into here and see how we are doing. Now that I'm looking at this, yeah, the function builder was actually stored by value and then sort of thrown away after it's done. Yeah, let's change this to be here. So we just say that this is not a pointer, but a real thing. And we will have to change quite a few things around to make this work. So first of all, this function will now return a pointer. And here, instead of creating it on the stack and then returning, we will do something different. So we'll just say that array push program functions and then function builder and whatever was happening over here. Okay. And a function builder star result is this stuff. And it was called builder, that's fine. Builder dash code. This is probably not the right way to do it right now. So we would create a label and we would resolve it right away. And instead, what we now need to do is to resolve it when we do the encoding. So that's, yeah, that's a fix me, definitely. fix me do this during the encoding. I mean, our code should still work fine, or at least it should build. But obviously now we have this issue with function because we changed from it being on a stack to being on a heap. So the function builder setup is kind of broken at the moment. Let's see what we can do about that. Well, it's pretty straightforward. We just need to change this to be a pointer right away. And it should fix a lot of the issues. But apparently not everything. Function builder star differs in level and direction with, yeah. So other places need to be fixed as well. Wherever we have this ampersand builder, now it will be builder, 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 and builder. Okay. Let me search for ampersand builder. This is fine. This is fine. Okay. Pluses are broken. This is what we can fix. Function reflect. If builder. Yeah. So we have a bunch more places to fix. Cool. Okay. Let's see if we're getting better. Still have a shit ton of errors. Okay. Function reflect. Fan reflect. Well, that should be fine now. Why are you unhappy with me? I guess because I was doing it manually. Yeah, all of these ones are now probably just the ones where I did it manually, except for the loop one. I will take a look at the loop in a second. Yeah. Okay. Where is the definition of the loop? Loop, 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 loop end. Yes. Okay, making some progress. Now we have this executable stuff here. And we don't have this type anymore. It is here. Okay. Yes. So now that we have changed how it works, we can change this code that writes out executable as well. So now it can actually use a function. It doesn't really matter what we are calling it here. I guess I can call it main, but it doesn't really matter what we call it. And we do want to save this thing as an entry point. So this should be like that. And then I can extract this stuff here and put this over to here. Result is not necessary anymore. This is not necessary anymore. And this is fine. Okay, we have more places where builder is used. I guess this is the second file. Yeah. Okay, so something about the case is wrong. make if. Okay. Good. We are building successfully now. Again, we will not. It will not really work correctly because we are not doing it right. I will run the tests because I'm interested in the executable. Is that still running okay or is it not? And we'll see afterwards. Okay, so executable seems to be still doing fine. And the rest we can try to fix now. Okay, so after we call this function one or multiple times, what's going to happen is we will push all the instructions into arrays, but we will not actually encode them. Okay, there now needs to be a way to encode all of these things. So let's go to function end, I guess, and put it somewhere close by. And I will call this void program end for consistency with function end. Have program star program. And now this is going to be quite straightforward. So we do a very similar loop, except for instead of instruction, we have function builders. So we have like all the definitions of the function that we have in our program. Builder functions. Okay. That's builder functions, except it's a program, not a builder. Okay, and builder plus plus. And for each of them, we just do call function encode of builder. Okay, that sounds fine. The only tricky part is that we now need to fix this stuff. So whenever we are encoding one of those, we would also need to say that we need to change this stuff. Okay. I also need to check who actually uses this builder.code because it will not be valid at this point. Instead, it will be valid over here. Builder code is builder buffer. Do we still have the buffer? Yeah, we do still have the buffer. Builder buffer memory and builder buffer occupied. Last point to struct or union. Yeah. Label is what? Label is result of this stuff. So I guess we have to store it on the function builder. Okay. Since I wanted to get rid of the code anyway, so this stuff, I guess we change this around and now say that we have label, I don't know, we call it function or label. I can call it prologue label. It's not really, I mean, it is accurate, it's just not the best name probably, but it is fine for now. So we do this here. And then it goes here. here we say builder prologue label. Okay. Let's try to build and see a bunch of errors that we can start tackling one by one. And as far as the code goes, we now say probably we can do this in code instruction. And the label is for builder prologue label. Yeah, that sounds fine to me. Okay. That builds, but I will open Visual Studio right away because this is going to be, I think, a bunch of debugging stuff. And I want to see what is going on when we run these things. Okay, first, I need to find a first test that actually does something besides the executable. And it is this one. So this is where we will test. Before we do, we actually need to call program end inside of this test. And I think I will change the setup of the tests between the videos so that in a similar way that we have the function macro helper, I will add a program helper and all the functions will be just inside of it. That will force some problems with looking up stuff, but for now it's fine. Or maybe I'll do it in a video, we'll see. For now though, program end of program. Okay. Does that work? Well, at least it builds. And let's try to debug this. Okay, this is very, very annoying. I guess I need to disable again this test. Need to figure out a better way to deal with this. But not right now. Start. Okay, we have program end. Let's step inside of program end and see what is going on. So we have this builder. We found one. We will call encode on it. And we try to encode this label, which is a label for the function. Okay, let's do this. Well, at least it didn't explode when trying to encode it. We do this, we go through all of the encoding. Everything is fine so far. It's quite a few instructions. I guess I can do like run to cursor or something. Yeah. Okay. That works. That label also got resolved. This is fine. We free the array and we are good. So program end successfully finished. Now what happens in our value as function? We assert that the label is label 32. Okay, that will be correct. Label has a target. That's good as well. At least it should be. Label does have a target. We return the target. Everything is great. Okay, cool. Let's switch to disassembly view and see if we are in the right place. So we do this, and now the moment of truth where we try to see if we generated any reasonable assembly. Let's step aside. Well, that assembly certainly looks pretty fine from where I'm sitting. So I'll just try to jump through that, and that looks perfectly fine. Okay, that's great news. I'll try to run the tests. What I expect to see is that we have this test passing and all the other tests, well, not passing. Let's try this out. Yeah, that's fine. Okay, should support short circuiting. Ampersand is passing. Now I will copy this stuff here, and it should be passing. So I can also copy it here. We now have a few tests passing just fine. Okay, that's good. I will not copy it now into all of them. Instead, I want to probably try this one because this is a tricky test case that has multiple functions defined. So we will need to make sure that all of them are like all of the offsets and all of the labels are behaving correctly, and we can actually encode multiple functions. But the trick is we always need to do this program and only after all of the functions are inside of the body. Okay, let's try to see if that works. Great. So it seems that we have it working and somehow have this stuff. Yeah, this stuff works because we are not actually calling it, which is kind of useless. Like we should be calling this check function. So let's do that maybe. But yeah, the main point is we have this stuff now working. So we successfully delayed the encoding of the function body to a later point in time in a program, and that should enable us to transition closer to being able to write executables for all of these tests. This will not happen this video. This will be it for today. But if you stick out now, then I thank you very much for watching and hopefully see you next time where we continue working on our compiler. Good luck.